or the offering from the Siemens. What are the things when you purchase solid edge? Then these are the things like under mechanical design, you have all the features related to modeling, assembly, drafting, as well as uh, uh, PNID, piping design. If you have a requirement of flow simulation related to to thermal or structural analysis, so all modules are separate modules are there inside solid edge. We have also integration with electrical design, so you can also do the electrical design inside solid edge, either the routing or wire harness or the PCB design. So all these things are also there inside solid edge. If you want to do the manufacturing or generate the CNC code, then we have a manufacturing solution as well, which comes with all the necessary features inside solid edge, and including the 5-axis milling. So we have manufacturing solution as well, and other features as well, like creating the technical publications, where you can create a work instructions inside the solid edge, where you can create animations, and also a PDF, 3D PDF, which basically explains the how to do certain steps to maintenance of any machines, or you can create a steps for the serviceability of any machines. So all these things can be done inside this technical publication inside solid edge. We have also inbuilt data management, but this is very basic. You can only do very basic kind of uh, PLM part, or you can say PDM part, not the PLM part, where you can create check-in, check-out, and you can just create a naming structure as well. So this is a very basic requirement, and that can be catered inside the solid edge uh, base module. And we have also a cloud collaborations, where you can use the solid edge portal to collaborate with other student or other colleges anywhere outside your faculty, college or campus. So these are the basically offering from the Siemens solid edge portfolio. uh, so basically cover all the aspects of the mechanical design, including design to validation to the manufacturing, as well as the PLM side. Let me go with the battle card for when I say battle card, basically we can also have why it is very important to know why the solid edge are widely used in other industries as well. So when I say how it has replaced many places with solid edge, whether that the current software is SolidWorks or Autodesk Inventor or any other software. So this solid edge has, as I explained, that the offering from the Siemens has a lot of to uh, uh, from the mechanical side or the electrical design side, or either the manufacturing side, or either PLM, or even from the control side also, or the sensor side also. So it has a lot of offering to uh, uh, do the job done, so the students can learn a lot of things, or all the things offered by the Siemens on a single platform. You don't have to switch the platform to learn the same thing. So when I say solid edge replacing the Autodesk Inventor, or it is replacing the SolidWorks, or maybe sometimes it is also replacing the Katia or PTC Creo. So when I say how it has been achieved, then there may be some challenges faced by the institute or the user who are basically using the existing platform, and they are not very much uh, benefited the features that is there, or the features they are looking for that is not there in that existing softwares, and that basically provided inside that solid edge platform. So when I say the challenges, these are the challenges where the users or the organization faces, and they have they have the delay in the product development, and again the product are not basically reaching on time in the market. So that basically is a lot of loss to the company. So when I say the challenges, definitely the Solid Edge has a lot of solutions to come up with the challenges. Maybe when I say that speed of mechanical 3D design, if I take this challenge, one of the challenge, then Solid Edge has one of the feature which is basically called synchronous technology, which basically speed up your design process in the software. Many softwares like Solid Edge or Inventor doesn't have that feature. This is the software. Solid Edge has the first time introduced this synchronous technology feature, where you can modify or you can design the component without keeping the mind how it has been designed, but just we want to get that feature, get that shape or size of the component. That then the synchronous technology will help you a lot to make the product very fast. And these are the features basically help the software evolve in time, and it has come up with you know at top of the competitions where other softwares are lacking. So these are the features, these are the challenges, these are the solutions from the Siemens, and how they have benefited. And you can also see how the customers has basically switched from one of the softwares like SolidWorks to Solid Edge, and they have transitions, and they have benefited from that Solid Edge. So similarly, we have another battle card, but the features are same to switch from one software to another softwares. So this is why basically this Solid Edge are very much used in academic as well as industries as well. The presentation I am going to use today, or the next day for the training. This presentation is also has been used or in one of the university at in America. So I'm basically using the same presentation which is used for the training of the student as well as the faculty members. So the same presentation, same files I am using, so that you can understand that this kind of presentation has been made to give the training to the students or faculty members in a much intuitive way, or to make the concept much understand much in a much easier way with a simple example, so that understanding of the software, the concept or the core concept of the software, it will help you to understand how the things can be made inside or design inside Solid Edge, so that you can build the system very easily. I'm using Solid Edge 2026, and I hope that you have installed Solid Edge at your machine. If not, kindly use that link to download and install on your machine. Uh, uh, Solid Edge, the latest version, because some of the files has been created in the latest version from my machine. So that will help you to open that file as well. So when I start, then definitely you will have icon on your desktop. You can click on the icon, and definitely the software will open, and it will display the interface. Uh, or you can search in that Windows search, type Solid Edge, and from there you can also open the software to start with, right? Now, when you start the Solid Edge, you will see this type of window, where you'll have a window for creating new parts, or creating a assembly of the active model, or drawing of the active model. Lot many things will be there, where you can create a new part, as I said, and you can also open existing part which is saved on your uh, local drive, or maybe saved on your cloud or shared drive. So a lot of options are there. So when you see this, you can start working either on the new part or existing part. uh, Now when you move then either you can start with the metric part, metric assembly. So you have to choose which unit you are following. So based on that unit, you can open your template for either for part, or template for assembly, or template for drafting. So then only you can start working on the software. So by default I am using metric, but you can also change it to inches, or what one of the standard which is basically there by default in this solid edge. So you can change this setting from the setting options, and you can choose what standard template you are going to use that. So this is how you can switch from one unit to another unit templates. Okay. So when you start solid edge, and when you say I have chosen metric part, then as soon as you open the metric part, you will see this interface where you will see the tabs, and under each tab we will see a ribbon bar which basically have all the features which basically does that job, right? If you are starting the modeling part, then you will have all the features related to create a model, which is basically created by starting with creating the sketch, constraining the sketch, dimensioning it, and then later on you basically convert it to solid, like creating extrude, or revolving about an axis, right? And many more options are there. So, or if you want to create a 3D sketch, like in a curve in a 3D environment, so that can also be possible. Or if you are creating a surfacing, then you can switch the tab, and you can choose the features to create the surfacing. So there are a lot many things are there to create it. So the tabs are there, and you can just choose the click on the tabs, and that you can then you can select the features to interact with, right? See, as I said, that you can create, like here also, if you want to create a box, or if you want to create a cylinder, or if you want to create a sphere, then there are options under this drop down menu. Click and you will find your command, and you can click to create it. So of course, this, as I said, that these are the this is the ribbon bar. You will find all the necessary features or command listed in that. Now when you have created something, and basically this type of softwares, or this solid edge software is basically parametric history based software. When I say history based software, whatever the features you create, like I have created a sketch of circular sketch with some dia, then it will be there in the feature list. Or here you can see there are three features has been created, like one feature is box, second is cylinder, and third is sphere. So all these three feature has been created in sequence. First it has been created as a box, then cylinder or sphere. So all the features will be created here, and it will be listed in the under the feature list. So it is basically feature based. And also when you click on to modify the size of the box, you can modify by changing the parameter value from, let's see, from 100 to 120 or 150. So like so the so that way you can make it parametric, and any modifications can happen through the parameters, which is basically uh, which are there inside in this features. So this basically have all the history under this pathfinder. So pathfinder, basically it is basically for uh, part design, as well as for assembly design, as well as for drawing. So there could be many applications inside this solid edge, and for each application there will be a separate pathfinder which basically contains the relevant features inside it. So I am in under this pathfinder for modeling, so I will get relevant features related to modeling. But I when I switch when I want to create do this simulations for validation of this component for a stress, right? And I do some kind of pre-processing, then boundary conditions, and when I solve this, it will give some result. So it will basically have a separate pathfinder where you get all the details of that simulation. So you'll have a different pathfinders you'll see when you work in the solid edge. uh, this is one thing basically called cube. I'll show you, but just quickly I'll just highlight these are the features. This is very important because if you want to navigate or manipulate the orientation of the component or the orientation of your graphics, like front, right, top, isometric, so you can rotate in any angle with this quick v cube. So this will be at the right bottom corner. So either you can click on blue part, or you can click on the arrow to rotate it. You can click on the corner of this to rotate to that particular orientation, or you can select the face to click to orient the component to the right, front, top, or you can click on the home button to orient to the default orientation. So this is very important to manipulate your orientation of the component, right? Now when I move, then there are some other options will be there at the bottom of that. Then we'll see during that working of this in the softwares. There are some shortcuts available when you want to orient the model with top orientation. Then you can click Control T. So similar, we have some more shortcut keys for the view orientations here. So just basically for viewing, pan, zoom. So all these options, all these features are there. When you click on the button, it will help you to do that pan, zoom, rotate, anything. But we have a mouse functionality as well, where you can zoom in, zoom out by. Let's see, if you want to zoom in, zoom out, then you can scroll the middle button of the mouse uh, to zoom in, zoom out. So these are the things available already there in that with the mouse functionality. One more very important thing is command finder inside this software. So any command you are not able to find, or it's somewhere there, but you are not able to see that command, then you are looking for, you are just scratching your head where it is. So this command finder will help you to find the features. Just type the name of the command in the search window, and just click on the search. So it will list all the commands related to command finder, maybe a command or maybe finder something, and it will list all these things. When you hover your cursor over that the list, it will basically highlight where the commands are. So this is very powerful feature inside this solid to find a command, and it will help you to locate where the command is. And once you click it, it will also launch, and you can use directly that feature. So that is how useful it is. Now we have the basic of 3D modeling. When I say parametric and feature based, then the base of all the 3D model is the sketching. We start with the sketch, which basically give the shape and size of the model, and the base will be a sketching where it gives you the core or the basic size of the component, and start with that, and later on you can keep on modifying to get the exact the feature, right? Maybe you create a block, and you extrude by giving some thickness to it, and then later on you want to add some hole, or maybe you want to add some chamfer or some many other features. Then you can keep adding on that the block, and you get what you are basically trying to create it. So the first the thing is the sketching, which is basically 2D created on a plane or any planar face available in that the user interface. So the basic will be the sketching, and then we'll create many more features on top of that. So we can see that when you click new create a new part, then under home tab we have all the sketching commands. But there is another a separate tab for sketching. When you click on a sketching, you will have some more advanced commands under that. So that is how we'll basically uh, find the sketching command in the tab or in the ribbon bar. Let's uh, create some feature and some sketch, and basically we'll see how this solid edge, how we start in solid edge environment, right? So I have started, I have opened solid edge. Let's close this and then I'll open once again. As I said that I have my shortcut key created, shortcut uh, created in this taskbar. Maybe you can search from here. I'll click on this and it will open uh, solid edge. Now the latest updated version of solid edge is named as design center. Earlier it was only as solid edge, but they have redesigned or renamed as design center solid edge, design center solid edge. So this is how the name will appear. Now when I open, I will get one tab. I have installed standard part library from 3D find it, so it is there as a separate tab, so I'm not going to that. I'll go to file, and as I said that we have this window appearing where I can go to file new, or I can browse to open a new existing file, or you can also look for the history, whatever the files you have worked on earlier. You can click on from this file list and you can open the existing file as well. What I'm going to do is I'm going to go with this new file, and as soon as click on that, you can see we have a new tab where I can start or select the template for creating a new part file, as shown in in the presentation also. Now, which standard template you want to use? Like I want to use isometric. Then I can select from this list isometric, or if I want to create in JB or ANSI metric, then the relevant template for assembly part, for sheet metal, for drafting is already created. So you can also have your own template, and you can list it here as well. So I'm going with isometric, and I'm going to create a isometric part.par. So the extension of part file is .par. The extension for assembly file is .asm. For sheet metal it is PSM. For drafting it is DFT. So different file extensions are there for different type of uh, templates, or different types of work, right? So I am starting isometric part, and I'm selecting the template and click OK. And when I click OK, so it will open the interface with blank, nothing there in that working area. Now you can see that there are different tabs as I shown in the presentation as well. There are many tabs. Now under home we have a sketch, we have some constraining object which is under relate section, and we have dimensions, all the dimensions type, and we have some solid creation commands and some more commands to make the component, or the object, or the model uh, you know fully constraints. We have some sketching, advanced sketching tools, 3D sketching. So all the features are there for surfacing. If you are working on 3D PMI, 3D annotations, we have a separate tools for 3D annotations on the PMI tab. If you want to work on a generative design, we have separate tools for working on generative design. If you want to work on reverse engineering, separate toolbars are there for that generative design, reverse engineering. Now when I go to home, we have we want to create a sketch. But before that, moving, we have two types of modeling. As I said that why solid edges are mostly used, because we have two options like synchronous and ordered. So I might by default I have checked synchronous. uh, generally people used by this option, which is basically ordered, where you start with a sketch and then you create a feature of like 3D feature, then you again create some sketch, or then you create the feature out of that sketch. So basically you are creating features, separate features for all that 3D separate uh, 2D features for 3D, creating some 3D out of it, right? And that is basically dependent, or that is basically following the parent child relations. So something you have created earlier, and on top of that you have created something. So the later one is basically dependent on the earlier one, the first one. So there is a parent child relationship. If you delete the parent, the child will also get deleted. So that is what basically ordered is all about. If you create in ordered fashion, so it will basically have a parent child relationship. You cannot delete the parent without uh, uh, because the child is also going to be deleted. So you have some restrictions basically, modifying the component, or how easily you can modify. Let's see, I'm a take the example, like I'm a CAE person, right? I have not designed the component, and there are some simulation has been done with study one. They found that feature is basically creating, and that feature should have some change in the dimensions, or that some sharp corner is there that has to be removed because some stress concentration is happening. So a lot many things are there, and that CA person doesn't know this component has been designed. What is the relationship between child and parent? He doesn't know, and he doesn't care about that as well. So in that case, he cannot modify it. He has to send the model to back to the designers, and he will basically design based on what input he has received from the CA person. So all this will take time. If that designer is basically on leave, and he's not there in the office, then again it is going to delay some with some more time. Now what happens is, when I work with synchronous options, what happens is that same person doesn't have to bother about what is that the sequence, what order it has been created. He just simply want to delete the whole. That's it. Or he just want to modify the dimension of the hole. He'll simply select the hole, and he will get the dimension will highlighted. Okay, this is the die of the hole. He will simply modify by changing the value of the whole die, and the hole will modify. He is not bothering how the hole has been designed, in what sequence. Synchronous will help you to design, modify things very quickly, without wondering, or without bothering how it has been done. This is how this is how it is powerful, this synchronous mode. So generally, the solid edge has basically you know giving us more flexibility by using this synchronous mode to design it, so that you can design, modify very quickly. And most of the time we are going to use this synchronous mode as only ordered. Basically you create a sketch, extrude, you create a sketch, and then you do some modifications, or lot many things. So that basically takes time. We'll use this synchronous. By default it is checked. If not, then go to tools and check this option, synchronous. Now what I'm going to do is, I'm going to create a some basic geometry, right? I'll go with rectangle. So as soon as I click on rectangle, before clicking any of the command, you can't see any plane, reference plane, on which I want to create some 2D geometry. Neither the plane, or the any existing geometry, nothing is there. So how to get that plane? By default, there are some base reference planes, right? At 000 we will get the principal planes uh, there, but it is basically hidden. So just unhide it, or let it be hidden. Once you click any of the command, then it will basically unhide, and it will show you. Now as soon as I select on the command, it will ask me to choose the plane. So as I want to create a sketch on this plane. You can see that as soon as I hover my cursor on this plane, it will show please lock this plane. So synchronous mode, it will ask you, okay, if you want to use this plane, just lock this plane, and it will be locked. Whatever you create, it will be created on this plane only. Now I have fixed this plane. Now I will go with one of the options like centered rectangle. So I'll choose the 000 as the center, and I will move the cursor away, and I can now enter the dimensions. Like you can see that length and width is basically displayed. So I'll just put some value, and I'll press tab to create uh, or enter the another value. So I will just say, and not 80, let's see. And the orientation of this the sketch, you can see when I have entered that value. Now if you want to orient in a certain degree, then you can also put the angle in that as well. But I want to just make it at 0 degree, so I will just click on, and you can see the triangle has the rectangle has been created with the dimensions which we have given. You can also modify the dimensions as well at the later stage. When I select on this, you can see the value is displayed to modify it. So if I say uh, not this one, if I say 80, if I say let's see 120, so now the value has been changed, and it is changed to that value. There are some symbol, you can see that there are some symbols applied automatically because some of the options has been highlighted. So while creating this sketch, that constraining, basically I have created a centered rectangle though. So the center of this line is basically aligned with this 000, and center of this line is aligned with the 000. So that way the rectangle is basically centered at this 000. And I have specifically created so that automatically applied, and it is basically fixed with that the this constraining. So this is very important when you create a sketch, and you can have that constraining applied automatically. You can see that maintain relationship is already applied here. And what are the constraining basically applied whenever I create a sketch. So for that we have a options under IntelliSketch. Under sketching, we have an option that these are the relationship should apply when software finds it. Whenever I create a circle and it touches with the edge of this is top top edge of this rectangle, and it finds that this is a tangent to that edge, it should apply tangency automatically, because I have checked that relationship in this IntelliSketch under relationship. So whenever a circle is touching this edge, a tangency constraining will be applied, a relationship will applied. So this is how that it is active. Actually, this is active, and it has been applied on this rectangle as well. Now what I have done, I have created one rectangle. I will create another rectangle on the same, somewhere on the same plane, because I have not changed the plane. You can see that this is already active. So I will just click, and I have created another rectangle. I want to create a circle on this, so I'll select a circle, and you can choose one of the options. So I'll just click on this area, and I'll just select the center and move away the cursor, and it will create a circle with certain diameter. You can enter the value, and it will be created here. Now if I say I want to create a circle on the same line or coplane, you can see collinear, uh, then I'll select the center of the first circle, and I'll click another circle that will be collinear. The center will be collinear, right? So this is how you can keep on creating these sketches. Once the plane has been defined, you can create. But if you want to create on another plane, just click, it will be off, the plane which is fixed, it is off. Now if you want to create a circle and you want to create circle on some other plane, then you can show the plane and you can now select another plane and you can fix that plane by locking this by clicking on this lock icon. So this is how you can choose the plane and you can create the sketch. This option, this locking option, is only active when you are in synchronous, but when you are in ordered, that option will not come. You have to select the plane, and in that plane you are going to create a the sketch. The lock option will not come. Now what I have done, what I have done, I have just created the rectangle, and I can select, and I can create uh, you know any 3D object, right? I have what I have done, I have just selected and created one of the 3D object. I have selected this also, and I am creating 3D object at here also. Now this is very basic thing where you have started with a sketch, and you can see that the features has been created here. So what we have done, we have created this first extrusion protrusion, and we have created a second protrusion. So this is in a sequence it has been created, and this is the sketch we have created. So we have created in a sketch in a single mode, or in a single uh, uh, one go, so that both are under this sketch 2, under same sketch. So this is how things has been created. Now if you want to, I have just created, and when I create a 3D, the sketch will basically get dissolved. So what we have to do, if you want to use the sketch, then you can right click and say restore, and the sketch will again will be restored, and you can use the sketch once again for creating another feature. So that is how you can you know uh, use that reuse the sketch in that. Now what I have done, I have created some feature on the sketches. Now there are some options, like this is when I select this face, and as soon as I select this face, one icon, you can see that this icon is basically give you the option of modifying this face. Means you can translate this face with some distance. So when I select on this, you can translate this face. When I go to this side, so the whole idea is that why I'm why we are why I'm saying that this is very easy to use. Now if I have to change the change the width of this model, I should have go to the sketch, then I should have changed the sketch of the dimension of the sketch, then the sketch has been come to that required dimensions, and it has been then modified it. Then there is basically you are following the hierarchy, and then the model has been updated. Now the person, as I took the example of say person, he doesn't want to modify this based on the sketch and how it has been created. He doesn't know that. So what should he do? He just simply click and say he just want to change the dia of the hole, or maybe the location of hole is not appropriate. Maybe this hole should have some other location. So from that, you just click on the hole and move it with some distance. The distance value you can put it, and the hole has been placed it placed somewhere. Now I want to change the face of this model, and now the component has been modified to this changes which I have made. So this is how very quickly you can modify certain things without bothering how this has been modeled. Now if I want to modify this and I want to extend this limit, I'll just simply select the limit, the top corner of this first component. Now it has been modified, and now it has been extended to that limit, right? So this is basically created. Now I want that this half hole to be moved somewhere here, right? Because this hole is now not needed to this part, because this we have modified it, and now we have added with each other, and the hole should not be here, but somewhere here or here. So you can just place the hole. Now the modification has been done, and how quickly you can do the modifications, and you are ready with your modified the component. So when I say synchronous, I mean with synchronous option, it is way faster, and you can do the things much easier and faster way. So this is why basically solid edges are very popular among the industry as well as academia, where you are doing something without bothering, because see, constraining something, but you are basically working on some research, some kind of concept, and then you are not bothering about how you are restricted by following some kind of hierarchy and something like that. Okay, you are not following, you are not going to do some kind of manufacturing right now. So synchronous is going to help you a lot in a very tremendous way to design your things very fast. So this is very basic overview of the modeling, or the concept, how we basically approach in that, right? As I said that we have to have a reference plane, and we have basically chosen and created some features on the reference plane as well, and we have logged the plane on which we are going to we have created some geometry. If you have existing geometry and on that geometry you want to create some reference or the sketches, you can definitely select that plane, lock that plane, and you can start creating a sketches on that, and you can extrude or cut or whatever you want to add material or remove material of that sketch, you can do that, right? So we start with this 2D sketch, extrude in which direction, in symmetric in either direction, or unequal distance with on both the directions. So then ultimately you are going to get a 3D geometry. This is important, as I said that because something you want to create it, and that has to be if the thing has to be vertical or horizontal or concentric, something has to be some relation should be there, right? So that will only be done through this geometric relations. As I have created a center rectangle, so the rectangle has to be centered about that the selected origin, and that because that geometry relationship has to be applied on that, so that we can say okay, this rectangle has is created at this origin. So the relationship, geometric relationship is very important when I say to position or make the degree of freedom of the the arrest the degree of freedom of that component is very, because you cannot you don't want that geometry will basically move just by simple mistake, and it rotates or it moved somewhere location, some other locations, just by you know by clicking the mouse or something like that. So you don't want to do don't want that to happen. Of course the if the rectangle is created by using the rectangle command, so all the corners has to be connected. Of course if a rectangle has been created, the opposite and the lines should be equal, should be parallel, so all this be automatically applied. But when you are creating some other lines tapered, and later on you want to make it rectangle, then manually you have to apply this the geometric relations given here in the software. So a lot.
Uh, Sir,
Yes,
Sundar
please.
sir. So
Yes.
whenever you would like to have bio break, so you decide time and the time of the bio breaks. Okay, time and
Yeah.
duration of the bio
Yeah.
break. Yes, sir.
3:30 is okay. No problem, sir.
Yeah, 3:30 is okay. We'll have a
Yeah.
bio break of how many minutes, sir? 2 minutes, 3 minutes?
I think 5 minutes is okay. No problem, sir.
5 minutes bio break. Yes.
Yes, sir.
So by 3:30 we'll have a five minute bio break, sir.
Yes, sir.
Yes.
Okay.
Yeah.
Okay. So this relationship is there if you want to make it to create a collinear kind of thing. So you can have collinear if you want to create concentric circles or tangent. Then we can choose, and you can select the two entities, and it will be created. We'll create some geometry as well. As I said that it basically detects automatically when you create a geometry, and it basically when it find some existing geometry, then it automatically applied the relationship based on what relationship you have checked. If that relationship is not checked, and basically it is if the arc is touching the line, and it is basically creating a tangency, but the tangent relationship is not checked here, so it will not create automatically. You have to apply it manually. Then you finish the sketch and then create the geometric constraining specifically or separately from this relate uh, from here, like tangent options. Otherwise, if you select from this IntelliSketch, during the creation only it will apply it. So this is very important. Some of the common relationships should be checked here. Smart dimension is there. You can create dimensions for line, arc, circle. You can create dimensions between two elements. Some other options or dimensioning, perimeter dimensions, or all dimensions are there to support you, right? So you can create chained, stacked. You can have angle dimensions. You can coordinate dimensions. You can have a angular coordinate dimension as well inside the software, so you can create coordinate dimensions for angle as well. You have a dimensions handle where you can position the handle, position the dimensions. If you apply the dimensions and it is not properly applied, then you can, or position, you can simply drag and you can position the dimensions as well. So the sub dimension handle is there, you can use that. If the dimensions are very big, you can see, then there are options to make it small based on the value you are choosing, how small the size of the font of this dimension should be. So that way you can also control the size of the dimensions as well. So let's see. I mean, if you want to create it, you can create a sketch in a very simple sketch is there. You can follow uh, you know so uh, these are the lines has been created, and the all the constraining has been created, like this line and this line is equal, this line and this line is equal, and also vertical, this is horizontal. The center of this line is basically coinciding with this point. So this is the center of this line, the midpoint of this line is basically coinciding with this edge, end of this edge. Similarly, this is with true with this. The center of this line is also coinciding with the this point, right? So similarly, this has been followed. This arc is tangent with this line. A lot many things are there. I mean, this line is coinciding, or this point is coinciding with this this center of this line is coinciding with the center of this midpoint of this line. So all these things has to be there, and I want to create a sketch by maintaining all the relationship, and also applying the dimensions, that okay, the distance of this line is 100 and total distance of it is 300, height of this line segment is 160, dia of this hole is 80. So if you want to create something like this, you can start creating on the plane, and you can apply all the dimensions, and you can do that. But the important thing is that how you approach this. I mean, this is maybe you can go to the software. Let's see if I'll just delete that. Let's see if I want to create that the same sketch. What I'll do, I'll again, as I here it is given like this, right? So this is important how you approach it. Maybe you can start with a line, you can draw a line like this, arc line, something like this. You can create it, and you can draw these things. But how to approach something is also a very important factor, because sometimes focusing on the segment of a sketch is very difficult. That will not give you a result very quickly. Just find out what is the core feature, core shape of that thing, and maybe you can use trimming and adding or extending some lines to get that required thing. So that will help you to get that result very quickly. Otherwise it takes too long to get that result. Let's see, if I want to create something like this, what needs to be done. So I'll go with this one. I'll click on this plane, and now the plane has been locked. I'll click on this front to rotate it, and what I'll do, I'll just what I'll do, I'll just make this as the center of that. So for that, let's see, I'll just use, let's see. So what I have done is I have created some base basic geometry, right? Now because what I am thinking is, this is the geometry, rectangle geometry, there is another rectangle geometry, and this is a rectangle, then we can add some, half circle to that, or circle, and then we can trim it. So this is the quickest way to create something. Like I want to create something, the say circle, and I'll just create here and another circle which is concentric with the existing one. Now what I have done, I have created something like that. Now I will, what I'll do, I'll just stream to get the required shape, right? So what I'll do, I'll just use one other tool called trim. Now it has been deleted, it is also deleted, this is also deleted, and of course this we will also delete it. Let me now this I have created, and it is basically, we are just nearer to that, the required shape, right? Now what I am going to do is I am going to make this line tangent to this circle to this line. So I'll select this two entity, and as soon as I select this, it will make the tangent, this circle with this line. Now what I'll do, I'll just let's see, if I trim this, it is trimmed now. Now what I have received is similar to this. Again there is a this one, and again there is a rectangle created, right? So what I'll do, I'll just create a rectangle, not by this but by this. So this is how you can create it. I'm not going to create a complete thing, but the approach is like this, how you are approaching to create in a less time, so that you focus more on to, getting the result very fast. Because if you start with line, then what happens is creating the curve, then it takes a lot of time. This is very basic, so at least you will get it done quickly. But if there is some more curves are there, then getting that curves is very very tough in a single go, and you will mess up with by while creating the constraining and applying the dimensions. So that will be a challenging task while creating all this, applying all the dimension and constraining. So the whole idea is that what you are doing is, you are basically picking up what will be the core feature. I'm talking about this rectangle, there is another rectangle, there is separate rectangle, and then again there is a separate rectangle, there is a circle, two circles, trimming. So trimming has given you a option that you start with the core shape, and delete it, trim it, and you'll get the final shape. So this is how you can create it. Now I want to constrain this line, align line with this midpoint of this line. So we have an option of this. Let me this one, this, you can see that now it is aligned with this. this has to be equal, so I will make this line and this line equal. And again, if I have to make this center of this and center of this, definitely if it is equal, then it will also be aligned. Similarly, this line and this line should be equal, that is also there. This is equal, I have done that as well. This should also be equal, this I have done it. Now I want to make this point and this as collinear, I have done that as well. This is also, this is not a tangent now, I think. So I'll do, I'll just make this a tangent. And this is not concentric, so I'll say make it concentric, this with this. Now it has been concentric now. So this is how you can make that geometry, all this geometric fully constants, where you basically apply all the dimensions, you apply all the relationships, so that when you move, when you move, or when you change any parameters, so it basically follow the relationship. The relationship should always be maintained while making changes, any changes to the geometry. So that is very important when you apply the relationship. Okay, so when I change it to 100, this is changed, but I think this is, it was not equal. So similarly you can make this equal, and you do all these things applied on this thing. So the whole idea is that when you create a sketch, make sure that you are applying a proper relationship, you are giving all the dimensions, and then you are making the sketch fully constants. Fully constant means the given, all the relationship or all the dimensions to arrest all the degree of freedom should be there, right? So there should not be any degree of freedom left uh, on this model, right? So this is how you basically create a sketch. Here you can see that same sketch has been created. You can see the approach, the same approach. And this is important, the approach is very important. And when you follow the approach, the things will be much easier to create it. You start with the, I mean, with the same positioning or relationship. You don't have to do it afterwards. You are creating in on the first place only, so you don't have to do it later on. And the trimming is much easier to do that, and you will get the result very quickly. Okay, so it is done. Okay, we'll break for we'll, join. Okay.
Sir.
Join back in 5 minutes.
Sir. So we will have a bio break here for 5 minutes. And
Yes, sir.
Santosh sir,
Yes, sir.
up till the explanation, for this 40-45 minutes. So should we seek some questions after the participant join from the bio break?
Yes,
Some
no problem,
queries?
sir.
Yes,
Yes,
sir.
yes.
So we'll have a bio break here, sir. Okay.
Yes,
Yes.
sir.
We'll join by 3:35 sharp.
Okay, sir. Okay.
Yes, sir. So, all participants, so let us meet post bio break. We can start again for the second session of the first day. Then, if any participant have any query or doubt about the last session, so we can have one or two queries right now. Participants, please feel free to ask your queries. Any participant would like to ask any query?
I would especially request the students. Okay.
Racer, we can't hear your voice clearly. Santosh sir, can you hear him?
No,
Sir,
no,
we are
sir.
not able to hear Racer. You
Okay,
can
maybe
type in the chat
they
box,
can
sir.
drop a, yes, yes, sir. You can type
You can type
message,
in the chat
send a
box.
message. Yeah. Type in the chat box. I will reply later. Okay, no problem. Okay, okay. ठीक है. So what I'll do, I'll go with that next,
Yes.
features like in the drawing only, in the 2D only, trim, extend, offset, fillet. How to use that to get the desired result. So let's see. I take same example which is created here. I'll just delete this. Okay, so here what I'm going to do is I'm going to create some lines and see how we can use this trim, extend, and offset and fillet command in this. So I have selected this plane. It is locked now. I am just orienting with the front, and now I am creating line. Here also lines. I have created 4 lines here. Now to get this result, how can connect this, and because I have created isolated lines, which are not basically connected here. So either what we can do, we have option of extending and connecting uh, these two lines, but here we can see that the line has been connected here. Also we have a fillet applied at the corner also, so the fillet can also be applied, and it can be applied with some radius value at this end as well. We have some offset also, so you can see one sketch is created, and it has been offsetted 4 times. So we can also offset and create 4 similar sketches with some variations, right? And then fillets, of course the fillets has been created. Now either we can join this to the corners separately and then apply the fillets, or we have option of applying fillets, and what I'm going to do is I'm going to apply fillets directly between these 2 lines. So when I drag and draw a pass this line which is basically intersecting the 2 lines, it what will do, it will intersect and create a fillet of 25 mm. So this is the quickest way to create it. Now what I have done, I have created a sketch which is basically connected and created with a fillet value of 25 mm at all the corners. Instead of joining the 2 corners, all the 4 corners separately, and then applying the fillets at the corner. So instead of that, I directly use that fillet and it has been created. Now what the requirement is that it has four instances, right, which is basically offset of the existing one. So I can select offset command from here, offset. I can select this sketch. Now distance of how much, let's see, I want to create a offset value with 5, again 5, again 5. So I have created some more sketches by using the offset value with 5 mm, and you can see that the sketches has been created now. Now you can see that the sketch has been created, and you can also see the relationship applied. It has been connected at this point, some connections, it has been tangent at this fillet at this location, so it has the symbol of offset. So many relationship has been applied here. Now you can see what is the importance of relationship, right? If I move this, you can see that when I move this cursor or any of the geometry, the whole sketch is moving, or basically honoring the relationship applied among the geometries. So when the relationship are not established, the design intent is not going to be maintained. Means every sketch will behave differently. It will not be the design intent is what I mean. It should be the always it should be offsetted of 5 with a 5 mm. This arc is always be tangent to this line and this line. The value of the arc value should always be 25 mm. So these are the relationship applied, and this intent has to be maintained. Means everything's, all the relationship or dimensions which are applied, it should be always be there. So this is how quickly you can create it. The sketch is created very quickly, and you are so trimming, extend, offset, fillet, it can be done and it can be created the sketch very quickly, right? Now while this whatever we have discussed, we have created a very a sketch where nothing was there earlier, right? You don't have anything, any geometry, existing geometry. So we had nothing, and we just selected the command, and we have used the plane. We have locked the plane, and we have started creating the sketch. Now suppose we have a we have a model, and we want to create a sketch in that model, or on the surface of that model, or any other feature of that model. So how to do that? So let me open one of the model which is here. Now this is a model. You can see there are two model. One is there is a inside body and there is outside. Two bodies are there, right? Now with this you can see that we have this one. What we want is, we want to create a cylindrical feature on the face of the inside chamber. Okay, there is a inside chamber, the green one. I want to create a cylindrical feature on the face. How to do that? Now when I say I want to create a dia for the cylinder, it will simply select the first feature which is basically interacting with, right? This is the first surface it is interacting with. I cannot go beyond this. It is basically giving, it is restricting me, it is not allowing me to go inside it. So how to select the internal feature, or any surfaces which is basically there, but which is surrounded by many other surfaces? How to select the how to select the surface you want to create something? I want to create a circle on the inside surface of the chamber. So what you have to do is, you just hover your cursor on one of the face. So basically it will highlight this is the face, As soon as you wait for couple of seconds, 1 or 2 seconds, there is there are there is a three dot icon. You can see that, right? Three dot icon, and it is there is also an icon of mouse, and mouse icon there is a right button highlighted, means it is asking you now you select or click the right button. Now there is a dialog box called quick pick. It highlights the surfaces which is near to that surfaces where you have hovered your mouse. You can see that now it has giving an option, okay, which surface you want to select. I want to select this surface. So this quick pick button, basically you just move your cursor, wait for a couple of seconds, it will pop up the three dot and also icon which click you have to, right one or left one. So we have to click right one. It gives me, okay, this is the surface I want, select on the surface. Now the surface is active. Now I can click sketch on the surface. I am done with the sketch. Now I can extrude that. Again it will not give me the option of selecting that. We have to wait again, wait for the quick pick icon, and then you can see it is highlighting the sketch here, the list that the sketch is in the list. I'll click on the sketch. Now I think it has selected complete. So here I can select it, and I think add it, and I can see that it has been created. So the quick pick this is also very important while you want to while creating something and you are not able to select the surface or the any feature you want to select. Then just hover your cursor nearby the face that surface, wait for some time, it will pop up the icon for quick pick, right click, and it will give you the list, okay, of the nearby faces, surfaces or features. You select from the list which is require surfaces, and you select the surface and you start creating the sketch. So this is how useful the quick pick is. You can see that how the complete process is explained here. Select the circle command, hover over the inside plane as shown, wait for quick pick to appear. It will appear here. Now it will give you the list under the quick pick. Select the required surface or feature, draw the circle, escape, again uh, click the circle by just again moving your cursor on this face. It will give you the option of selecting the circle. Select the circle and then extrude it. So this is how quick pick will help you to select the desired or the required surfaces. So these are the sketches given for exercise. Do you want some time to 5 minutes to create one of the sketch? Is it okay? Any of the sketch? If anybody has installed software on a system.
Yes, sir. Yes.
Maybe 5 minutes, 3:55 will.
So, do we have to do one or both?
Anyone, just to have a just to have an idea that how we
Okay.
basically create this in
Okay.
this software.
Okay. Sir.
You see how you approach that creating that, okay, that is more important, and also all the relationship has to be there and dimensions as well.
Santosh sir, there are some
Hi, yes.
queries in the chat box.
Okay, let me see.
How to change XYZ coordinate to
हाँ
XY?
sir, there are few questions in the chat box sir.
नाही 5ला देणार आहे 5ला निघणार का रे? हा. निवडा नाही.
Okay, here. Okay, so let me create a new file, and the question is that, I mean, this is XYZ, and the question is that how to make it a XY plane. I mean, the plane in which the user wants to create the sketch, right? This is the question. Now what here we are doing is we are creating everything in synchronous mode. So when I want to create a sketch, so this plane is highlighting, right? This plane is highlighting. Based on which plane you select, suppose I am selecting this plane, right? If I select this plane, so now this plane is selected, and whatever we create on this plane only. So if I say, if I rotate, orient this as a front, you can see that. Now you can see, you will not see that X or Y, I mean, something which basically shown in other softwares where you follow the ordered kind of thing. Here what it is giving is, whatever the plane you are, there will be X and Y only. Z will be always your third direction. So when I uh, click anything, any plane, it basically, when you say front, it will orient to that orientation, that plane. It makes that plane parallel to the screen, and whatever you create, you basically following the X and Y things, right? There will be no Z will only be when you, while extruding. So when you extrude that, it will be extruding in this direction. The thing is that we have selected that plane. Or if you want to create another coordinate system, basically where you have a uh, plane, something like kind of this, right? X or Y, then you can create a separate coordinate system. If you want to want something like this, not the default one, then you can create something like this, right? If I close this, and when I select this circle, and now I can select this, the plane of this second coordinate system. Now when I click on this, say front, you will get this X and Y. In other softwares, what happened is, you, whatever you plane select, either you select ZY or ZX, the plane is the same, but what happened is, the when you go to that plane, it basically give you a 2D interface where only XY axis coordinates are there. So it basically converts X and Y, but here you don't have to bother about whether it is showing or not. It is always the XY thing, nothing to be shown here, but it is always XY.
Sir, I've tried that profile. I've created one profile.
Okay.
So
Fine, sir. No problem. I mean, it was just an example, or kind of a tutorial where you can just have a hands-on how basically create a sketch where, starting with the profile, trimming it, giving the dimensions, applying all the relationship, then only you will have a proper the sketch. So the whole idea is that only, not creating the sketch, but whole idea of understanding is that how to start or create a profile. If that profile is not a rectangle, if something other profile is there, then how to approach that, what to create, and what to trim, and then creating and then applying all the relationship, because the relationship is also important. Okay, because if that relationship is not there and you're assuming that everything, the two circles are concentric, and you move one circle, the other circle remains there, so that is not correct one, right? You have to apply the relationship to make it concentric, while creating the sketch only it has to apply the concentric, while then only you can say, when moving the one circle, the second should also be moved along with this, because the relationship is concentric. So the intent is followed, means the intent was that when I move one circle, the second circle should always move. So that intent has to follow, otherwise there is a problem with this sketch. The whole idea is that only, I mean, all these sketches should have the dimensions and relationship, nothing else. This is example of one sketch where profile has been created, and if this point is moved, the whole sketch is following the same intent, means all these sketches are basically moving and following the intent or the relationship and maintaining the same shape. Size is changing, of course, because dimensions was not there, but maintaining the same shape. You can see in this video as well, the sketch was created, and you can see that it has been created, and other geometries are also created, and also, so you can see that because the point to point connections are there, and it is basically changing based on that. Now it is collinear, right? Now it will always be collinear. When one of the point will move, it will always be collinear. Now we are creating some certain sketches, and there are some constraining or relationship applied, and there are some equal sign given to the geometries. This slant lines are basically equal to each other, and some of the geometries are basically aligned with each other. So that is basically you are applying a relationship to maintain a design intent. So if that intent is not maintained, then your relationship is not properly applied, and it will behave, the sketch will behave something differently. Now, all the relationship has been applied. Now you can see that with one point, if I change, drag one of the line or point, anything, it basically maintain the relationship. Okay, the shape is same, but only size is changing. But of course that will also not change if the dimensions are applied. So this is how basically you create the sketch, and that has to be there in that way only. Now we are moving to the next topic, is enhancing creativity. Basically recognizing, as I said, that we have created the sketch initially. How we are approaching, recognize the simple 2D shape. Okay, and if there are patterns, also if there are something which is patterned, then you also recognize, okay, oh, this is the simple shape, and of this simple shape there are patterns of that shape. Then then if you recognize the things, then you basically create the geometry very quickly, and also you will have a better approach of uh, creating the geometry. That kind of things are there. So here also it is very important that you recognize the basic or the simple 2D shape. Then you create the 2D shape is rectangle or circle, create it, and then you trim it to get the desired one. So that is very important to approach. You can see that recognizing shapes and pattern. Recognize, I mean, if you want to create something like this, what is your approach? What will be your approach? If I want to create a rectangle and this four arc, what will be your approach? So somebody will create a rectangle, and then create a arc of with some diameter, whatever the diameter. So they will create separately this diameter. Maybe someone will have some other approach, like what will he will create some rectangle, and if he recognizes that, okay, the shape is basically, it is the circle, and if I create a circle at the center, at this corner, this four corners, I will have a four circles, and then I can trim the outer part of the circle, which is basically outside of this rectangle, and then I'll get this. So this is how you are basically recognizing, and you see that these are kind of pattern kind of thing. This same thing is this side also, this side also, this side also. So once you create this side, either you can pattern it, or you can create four different uh, four circle at four different corners and trim it, and you'll get the result. Let's see. I mean, if I go to this, and if I go to this, and I'll just delete that, and I'll say here I'll create a rectangle, centered rectangle, and let's see, 100 mm and 100 mm. Okay, I have created it. Now I have recognized that, okay, the shape is basically circle. So instead of creating a creating a arc, I'll create a circle by at center of at this location, and we will the center and the radius will basically, or dia is basically the half of this length. So similarly, I'll approach to this side, I'll approach to this side as well, and I'll create to this side as well. Now I have created this, and the simplest way is to trim it. I'll get the result. So this is how we can approach to anything, and then we will have a better understanding of how to create it. If once you recognize how this what are the shape, or what is the pattern inside this uh, okay. So this is how you can create it. So this is very important that you understand these things. Now the next same question is that, what if you copy and rotate? What will happen if you copy the same things and rotate? What will happen? Now somebody asks you how to create this, then what you will do? I mean, then again you have to, what you will do, you will create something like this, one sketch for this, then second sketch, or maybe arc something, and then corner. Means you are starting with the arc command, and you are starting from here, creating the arc, again a small arc, big arc, small. Maybe you can approach like this, then again you are again creating another arc with the different new command, and start creating like this. So I mean, this may, you can achieve that result. I mean, you can achieve that, but the thing is that that takes a lot of time, and lot many things may happen, right? But once you recognize that, okay, this, the magenta and this one, yellow one, is the same, it's just copy of each other, and it has different angle, nothing else. So once you recognize, okay, this is the shape, okay, and this is the this is that one rotation, right? So once you recognize, you can create it. Now what I have done, I have created this, and what I'll do is, there is a fillet here. Now once, if I recognize that this is a fillet here, what I'll do, I'll just create a fillet of, let me create a fillet of 12, 10. Okay. 10, 10, 10. Now what I have done, I have just selected and I have created it. It's similar to that same thing. I mean, I have applied a fillet of largest value, but this is the same thing. Now what I recognize that, okay, this is basically a rotation with some angle, and now the shape is same but it with different rotation at some rotation. So what I'll do, I'll just select this geometry or the inner profile, and there is an option of rotate. When I click on rotate, there is an option of copy also, because that is a copy. It's not, I don't want to rotate the original one, I want to rotate a copy and then rotate the copied one. So I'll what I'll do, I'll just check this option copy, and definitely I want it for maybe you can define some angle as well. Let's see, I mean, uh, let's see if say 30-degree. With 30-degree I can rotate this about this axis. I have selected this center, and starting is this axis. So about from this axis it will take 30 degree to create a rotation. 30 30 30 30 30 30. So you can see that what I have done, I have created the profile by using this rotate command, and you can see that, I mean, the profile is, the original profile was the profile is the same. Only thing is that other profile is only rotated about center of rotation with some angle, nothing else. Here is same variation, there is a variation, but because of rotation with some angle we are getting some new profile, nothing else. It is similar to the original one, but the next profile is basically rotation of the original one, the first one. So this is how basically you have to see the things. When you see the things that, okay, this is the, I mean, the actual feature, the core feature, and this is basically pattern or copy of this, then you can do that things easily. Here also, when this is very very I mean, fascinating. I mean, everybody can say that, okay, these are very different things. All these patterns are same, only the center of rotation has been moved slightly, nothing else. This profile is same, nothing, there is no change in that profile, only that the center of rotation has been moved slightly, and you are getting a different results. So I mean, there are many things we have to understand the software, how this software works, how this software can be used to get the things, how the features basically works, how the commands basically works. I mean, just the example of rotation. So it will give a different results. Now same question here also. I mean, how to approach this? I mean, if someone asks you to create this, how will you approach this? Again, you know that, okay, this is one feature, and again this is a pattern of this, right? But again, creating two curves is also a very I mean, either you create two curves, but again, this is the same dia, this arc and this arc is the same dia. So start with this curve, but again, creating a curve is again a tedious task. Arc is creating a tedious task. Now creating a circle is very easy. So in this case, what has happened is a line has been created, straight line, and with the center of that line a circle has been created, and only half circle has been remained and other portion has been deleted, and then it has been patterned or created a move by some angle, and it has been created. This is how the geometry has been created. See, the line has been created, and from the center of that line the arc, the circle has been created. It's very easy to create the same arc. It's very easy to do that, and now that has been rotated and created the instances of the same arc. You can choose any value step. So at that step it will be created the different instances, and of course you want to create a copy of that. So this is how you can approach. And just to tell you, I mean, in Mumbai, there are many jewelry design companies are there, those who design jewelry. So they have many companies are using solid edge for designing the jewelry. They have many add-ons on solid edge where they design any complex design of jewelry by using the solid edge. Here there is some notes, like try to stay away from drawing in segments. As I said, that don't try to create a segment, look for complete shapes and trim. This is a tips, you can say. Now this you want to create it, this you want to create. To get this started from here, then trimmed, and this has been created. And after this creation, some other features has been added here. Now it has been rotated and it has been created here. See, I mean, this is complex, but started from very basic shapes. This is the shape, this is the modified shape by trimming, and the ultimate result is this is how it has been created. The same pentagon has been used and it has been created. Now it has been trimmed to get the okay. Now other things has been created, like ellipse, other part of this you know to complete that complete sketch. So this has been created here. Now it has been the center of rotation. For that, it has created a circle, and that will be used as a center of rotation to rotate to create a multiple instance of this object. So see, this is a very basic approach to create this. So definitely, I mean, sometimes it is very uh, looks very complex, but it is very easy, very simple things, but we have to visualize the things and then we'll create it. This also looks very complex, but this is very uh, uh, simple things. Here also I'll just run the video so that you can also understand how it has been created. It has been started with one pentagon, and it has been offsetted with some value. So there is a two pentagon created, and one, then after that, then it has been created a copy of that, and there is another copy of by rotating that. So with this, the same feature has been created. You can see that the main feature, the main the core feature was basically pentagon. Hexagon, here is hexagon. So one is hexagon. After creating one hexagon, others are copied and others are basically pattern or rotated. So I'll just quickly run that, and you can see pentagon hexagon has been created, and it has been offsetted with some value. Okay, and now you can see that the same has been moved and copied and moved. Okay, and again that one is also moved and copied and moved to the other side. And now the rest is actually rotated, all these three. With a step 120 degree. So at 120 degree, about that center and about this axis, it has been created. It's done. Now some of the portion has to be trimmed, so it will be trimmed, and the remaining will be there. Now get the result and extrude and you'll get the final thing. So whichever region you don't want, just click on the shift button and you select and it will be deselected, and now everything is green is selected and you are get the result. So this is how the approach is. I mean, you have to just recognize, find, and you will get the complex thing done in very quickly. You can see that. I mean, this is a Penrose triangle. I mean, impossible to create in 3D. But how to create in 2D is also a, I mean, you can create it. So this is again a very good example where you can create that kind of geometry just by understanding how we can approach it. So it is started with a triangle, uh, started with a triangle. So the orientation is something like this, and it is basically the triangle is offsetted, that's it, and trimming, nothing else. It was offsetted, and some more geometry has been, some extended has been done. So some geometry has been extended, and extended geometry, some of the extended geometries are basically trimmed to get the result. So some more geometries are getting created here. So basically, which is not desired, it has been deleted from this, and you will get the required one. So you can see that, I mean, that same shape has been created in 2D, but in 3D this is not possible, definitely. But I'll just show you the the example which has been created. You can see that it has been created here, but it is just because the orientation is something like that only. I mean, it is not possible to create it, but it looks like, okay, we have achieved that, we have created the impossible, but it is not. When I rotate it, you can see that it has been created in that, but the orientation was such that it appears that, okay, it has been created, something like that. Okay, something like that, it was oriented and it seems that it has been created. So that Penrose has been created in 2D just because you have a approach, you know what to create and what to delete, and then only you can get the result. Now when I move to 3D, basically we will just see how to create certain things, and how innovative or how intuitive in your thinking is that, how to create certain geometry, or how to get that basically shape. Now when I click on, when I see this picture, how to create this, I mean, it looks sometimes is difficult. I mean, this is the curve created and there is a hole. I don't know how that hole is created, uh, on which plane the hole has been created. You may be get as amused, I mean, how it has been created, but this is a very simple thing has created. Let's see how it has been created. When I go to file, new, and uh, I'll create a sketch basically, or block, in fact. So I'll create a box here. So for box, I will use center. This is the plane on which I will create the shape. So let's see, create 100 by 100, 100, and orientation is okay, and now I'll extrude to 100 as well. Now what I have done, I have created a block, and when I see this thing, you can see that at one corner it has been created as a trimmed with some kind of sphere, spherical shape is that, okay, though it is not there in that there is no drawing for that, but I want to create something like this. I want to achieve something like, not as per dimension, but I want to get this a shape like this. So what to do? What we can do is we can create a sphere, and I want to cut it. So from here, add and cut, I have selected cut, and I will create a sphere with a center of at this corner. Now I can create, and you can see that it is creating as a cut, right? So now I can see that, okay, oh, this is how it has been created. Now how to create this hole? The hole is not created by creating a hole feature. No, it is not has been created. The same sphere has been created at this to this side. The same sphere has been created to this side, keeping this corner as, you can see that as I move, it has created this, because here that's not showing the other side, but the shape was like that only. It has created, and now you can see that it has been achieved, and what is remaining is the thing, right? And now we can get this result. So this is how, I mean, something, if you are thinking and you want to create it, it's it was very simple. It was, right, creating a block, creating a sphere and trimming it with the block and creating a blend. You got the result. So again, you have to think here also how to get any, if you have something in your mind and how to get that, you just think and you can create it. Here, I mean, after creating, there are some more features like rounding or you know, chamfer or anything. So suppose if you want to create a chamfer round, we have created something which is basically, you know, selected the edge and we have created the chamfer round. If you want to create a round here also, I can select this. Let me give 5 round. I want to create it, and I will give a value of 5, this. So I can select the edges, multiple edges in one go, and can create it. If I want to create a corner round to this edge, so I'll select and I can create this. Now the important thing is that in which sequence you select it. Now you can see that at this corner, at this edge, the blend is, or the round is very good, okay. So it is, the flow is very good, right? But it has been created in that way, where we have first created the blend to this edge, these 3 edges, and then blend to this edge. If I create a blend to this edge first and now to this edge, we are getting the same result. But sometimes you have to also see the sequence is proper or not, because the sequence matters most in some of the cases, where you have to apply the round to this edge first, and then you move to create the round to the other edge. So then only you will get the round properly, otherwise the round will not get properly created. Here in this case, here the rounds has been created, but the rounds has been created to the edges, at the outer edges, not to the inner edges first. So what happened is, when you create the round at the inner edges at the last, you will get a different result. Let's see this one. Now you will have this result, right? This is the result you are getting it. But when you follow some other this is not good, okay. This is not, though we have created the blend round, but that was not good, okay. For forging or casting, that is not good. So what happened is, now the blend has been created in one go, and now you can see the flow of the blend. This is how we can approach this. So this is also important, in which sequence you select the edges to create the blend, and the blend will be created uh, properly. Now here also the blend and the thin wall, I mean, if you want to create a shell feature, how you can approach this. Now I have created a geometry for this. Let me open that. uh, the name of that is thin wall. I have created three circles. Okay, I'll just restore it. I have created three circles, so I'll create three different cylinders using that circle. So I will click on this. I will use this first circle to both the side, first one, then I will select this one and extrude to this, and I will definitely add it to the first one, and extrude to the third one, and definitely I will add to the first two one. So now what I have done is I have created the geometry sketches, and then I have created a solid geometry, and all are basically united. So once it is united, you can see it is, there is a sharp edges there, so it is united now. Now I will create a not this one. This one and this one. I say okay. Now so what I have done, I have created a round to this, so it is properly created. Now if you want to create a hollow section to this, so there is an option of thin wall. You just select the faces. This face will be removed, and the object will be created. So as soon as this face is removed, there will be hollow sections created, right? So when you want to create a section view, shell feature, a hollow feature, then you click on this and select the face which you want to remove it. So it will create a pipe kind of section. But if you want to create a section which is basically hollow from inside, but it is closed from outside, then there is another option, excluded face, means the faces which you select will be excluded and other faces will be removed. That is how you can like a tanker or something like that. I mean, if you close cannot if you don't select the faces which to be removed, so what will happen, it will create a hollow section from inside, and it will not create a opening from any of the sides. So that kind of geometry, if you want to create, you can use the second option, this one. So this is how you can create a thin wall. That is not very complex thing. This is again same thing. I mean, there is a box created, and there is some mirror features has been created. So if I say mirror feature, let me, okay. So I have created this again, earlier one same, but how to replicate to other side as well. I mean, this cutout is to this side also, this bottom side also. So there is option of mirror feature. I'll select this feature, and there is option of mirror. I will select the mirror by selecting the plane, and now I want to mirror this two feature as well. So one is selected. To select the second one, I'll press shift button and select the other one, and I will now select the plane. So this is the plane I want. Okay, no, okay, let me select both the thing and mirror. I think I forgot to select, and now this is the, and now I will go to select the other two faces, because the mirror is to that side also. So now you can see that the mirror has been created. So if you want to create mirror of any feature, you can select the feature and you select the plane, and it will create a mirror about that plane. So simply you can get that result. Now one thing is that when you create any feature, you'll get dimensions. So when I create a new I'll create some kind of geometry. So I have created a geometry and I'll apply some dimensions to this. Some dimensions has been applied here, and you can see the dimensions are there. Let me delete this. Okay, now the dimensions are in red color, means this is basically log dimensions. Okay, and whenever you create a sketch, it will be highlighted in red in color. So basically this shows that this is a log dimension. Now as soon as you extrude this dimension, extrude this, as soon as you extrude this, the dimension will change to blue, and it basically it is unlocked now. Okay, so this is the only difference of the dimensions. Now this is locked, this is unlocked. When you move any dimensions to this, it will, you can see that this is changing. Okay, so synchronous, when you work with synchronous, so as soon as you move the face, the dimension will also get moved. But the red one, when you lock the dimension, in this case when you lock the dimension, what happens is, you can see that as soon as the extrude has been done, it basically changes, and you can see that when you move, it changes. But once you lock this dimension, what happens is, it will not move, it will remain to that dimensions, the lock dimensions. And when you move the face, you can see that the dimension will not change. So that dimension is locked now. Other dimension, the blue color dimension, will move. So that is the only difference is there in that thing. So whenever you create a sketch, it will be in red, it is locked. You can change the dimension, but that is for synchronous. When once you apply the synchronous feature like moving the face, so it should change the dimension as well. But you want to make sure that dimension, this feature length should not change, then you make sure that the dimension should be locked. Okay, just hold on. Okay, so now when I'll move to the new section, which is basically a construction geometry. It basically help you to create a geometry, like if you want to create something, then you sometimes it is not easy to create in one go. Something it requires to be there, and then with that help something you can create it. So something which is help you to create, you can create as a sketch, and create the final sketch which is actually required, and convert that the original one, which is basically help to create the certain feature as a construction geometry. So that will not take part in the modeling, that will be ignored, and other geometry will take part. So basically it help you to create certain things, certain features, certain profile, but it will not depend, but it will not take part in the actual modeling. So you create it something like that. In this example also, when I say, for this example, I mean, I want to create something like this. So nothing is there, then it is difficult. I mean, I have to create this two circles, this two circles, then I have to do lot many things. You have to dimensions and something like that, lot many things I have to do it. But if I create a uh, let's see, if I go with this, and then I at four corners, I want to create this geometry, right? So I have to create two circles. Then here also I'll just select and something, two circles, then something like that I have to do it, right? But it is very easier to create with the help of construction geometry. And I know that these are the four corners I have to create it. I'll simply create whatever the diameter is. I'll select the appropriate, and I have selected this because this is not required now. So what I'll do, I'll select and I'll make it as construction. Okay, so this will not take the part, but it has helped to create the four circles at a particular location. Location is the distance, the length and width of this rectangle. So at that location, that circle has to be created. It is easy to create with construction geometry and create it and make it as a construction later on. So that is helpful to do that. I'll not go with this radial right now. We'll see later on. Okay, so this one is again uh, when you have created a sketch, or maybe if you want to create something like this, right? I want to create something like this, and I have a dimension of this profile or this profile. So I mean, what is the approach? I mean, should I start with this or should I start with this? Should I create this sketch or this sketch? So I mean, this is also important. I mean, which sketch should I create? And this is either here, any of the two is okay. So either you create this sketch and extrude it, or you create this sketch and extrude it and add some more features on top of that. So this is basically important, how you approach if you have to create something. And sometimes the dilemma that whether we should start from this side or whether we should start from this side. So make sure that I mean that if that doesn't make any difference, then you can start by any side. Now next is revolve. Of course, if you want to create a geometry about which has an axis, then you can use that revolve command. Uh, like this, I mean, if you want to create a bottle, then how to use the revolve. So you can, I have created a geometry profile like this. So if I want to create a revolve, I will select this. And the important thing is that you have to define the axis. Now sometimes axis is not at the proper location. So this is important, that your axis is about this. I mean, this is the axis, this will be your axis. So this wheel is important. In now you have to define what is the axis. So now if I align this, so this will rotate about this axis, vertical axis. Now when I move this and align along this edge, now this will rotate about this axis. So this, to define axis, this is very important, how we are placing it. Okay, now I want to rotate about this axis, so I have placed this, and you can see now it is rotating about that axis. And here you can give the angle. I have given 360, and now it has been created. Now on top of that, you can add some round or whatever you want to create. Okay, create it. So this is how a revolve works, even for okay. This is also a symmetric revolve. I mean, you can create a revolve profile. I mean, just by both sides you can use that. I mean, here we have a revolve, and you can use that symmetric. We have extruded in a symmetric direction, I mean equally in both the sides. So similarly you can also have a symmetric extent where this side or that side the angle will be same. So that is also possible to create that. Here the same. Okay, now a design intent. I mean this is very important uh, when you work in solid edge. This is really very important. I'll just tell you what this design intent is. Now say suppose I have a, this is the geometry. We have three circles, three holes, and three are all aligned and all are equal. So mostly when you see from this half, the if I cut from middle, both sides are symmetric. Okay, with dimensions, everything it is, all the features are equal. The size and shape of every features are equal, right? Now the requirement is that when I move this uh, the the circle, and I want that this circle should also move, right? This, when I select this circle and when I move this circle, I want that symmetric to this circle should also move. So I select this, and when I save this, it is moving like this, right? Uncheck everything. Now when I move this, you can see that there is no design intent followed. So it is independent. Now it is its own. So nothing is followed, right? So no symmetric. If I say symmetric, it will find some symmetric to this hole, and it will also move that symmetrical object along with this hole. So I want to define a design intent, a symmetric one, to this hole. Now if I move this hole, what happened is symmetric to this hole should also get moved. So this is the intent, a design intent I want to define while moving this hole. So this is one thing. I mean this is how I want to make changes to this geometry. Similarly, what we have seen earlier also, I mean if I make move any point of the sketch, now you can see that you have seen that the whole sketch is moving with the same offset, same radius value, the blend value, and all things. Here also we have in 3D we have design intent, and we have just hold on. When I say centric, this one I think. Symmetric as well as, let's see, I mean I don't know. Okay, so when I see this one, let's see this one and say symmetric, is it? You can see if I say select this face, and when I say symmetric, these faces are moving also. If I select everything, and when I select the concentric as well, so what happens is when I say this one, let's see, I mean what it will move, this one, and if I say offset, so it will offset also any aligned holes or coplanar. Let's see, I mean aligned hole, right, is not moving. Maybe let's see. Here also, if I say select symmetric, then what happened is when I select this, it will move this symmetric. If I say coplanar, then what will happen? Whatever coplanar, whatever the face which is coplanar to this the selected face will also move, something like that. You will see that, right? So this is how basically design intent is is important. How you want to behave when you are doing some modifications, you are moving some kind of features, and you want to maintain that the movement of other features are also be aligned with the first one, right? So that for that design intent is very important. So this is very important when you do some kind of changes. So this is important when you use the design intent, right? So maintain concentric faces. When I select one face, and when I select that the other face should also always be concentric. So this face to this face, this is concentric. I mean the axis, the center of this face, this whole will always be concentric to the center of this. So when I move this, all will get moved coplanar. So when I select this face and select the coplanar in the design intent, so any face which is coplanar to this will also get moved. Here also, I mean symmetric, any face symmetric to this face will also get moved. Offset, right? So any face opposite to this face will also get offset, means just similar to or the other side of this face will get moved, means something like a mirror face. So that way the intent will also get uh, applied. Here also aligned face, I mean aligned hole, any hole which is aligned to that hole will also get moved, something which you have seen. So this is important that you use that, and you maintain the intent by selecting the things. Okay, so plane we have selected and created the plane, and we have on any face you can create and select the plane, and you can use that to create any geometry. Here also, let's see, I mean I think if you want to create a custom plane, so you can select plane, and if you want to create a parallel to this surface, so select this surface, a plane will be created, and with that cycle, or you can say that cube, not cube, that this one round, so you can move that and you can create a plane away from this or offset from this. Now we have a separate plane, you can create any sketch on this plane, and you can create some features. So similarly, if you want to create a plane with other options as well, like if you want to create a plane with 3-point options, so I'll select first point, I'll select second point, and I'll select the third point. So a plane will be created passing through all these 3 points. So similarly, other options are there, like if you want to create a plane tangent to that, so what we can do is we can create a plane tangent to this. So I want to create a plane on top of a plane which is tangent to this surface. So what I'll do, I'll select on this option tangent, and I'll select this face. So it basically select this face, and it start takes a x-axis, and from x-axis it will give you a angle at which angle you want to create a plane, but that plane will be normal to tangent to that surface. Okay, so you can create a plane, and now you can create some features on this plane, and you can do some kind of geometry creation, and you can extrude, cut, and something like that. So that way you can create the features, right? Okay, now project to sketch. See, suppose if you want to project something, take the example of this, right? You have 2 components, and these 2 components will be bolted together to create an assembly, and to create the same hole dia or same locations, you have to have the the details of this hole with you. Otherwise, you cannot create the hole on this surface. But if you have if you are creating assembly, you have created this component and you have created this component at later time, you can use the existing feature to transfer that on this the other component, and you can use that to create the geometry as well by using the project to sketch. So I will use this the edge of this hole to project on this surface, and that projected curve will be used to create the geometry. So this is again a good feature where you can use that capability. Like I have option of creating project sketch project to sketch. So what I'll do, I will select, this is the face, and this is the surface onto which I will project the edges. So I will just this option will come. So what I'll do, I'll just select this edge of this hole. Now you can see that this is projected on this. Now I'm done. And now what I'll do, I'll project the other this one, slot one on this. So I will select this surface to create a plane, to fix the plane. And now I will select the edges to create the sketch, right? And now I will extrude that to and now I can create that, and here also I can. So this way we can use that project to sketch options to create the thing. Okay, there are many options. Can we continue for half an hour, or how we can do that, sir? Hello.
Yes, sir.
Can we continue for half an hour, or how? I mean, can we continue tomorrow? I mean, I'm just asking.
So timing is up to 5. I'll just confirm with the Rajurkar sir. Just wait.
Please, sir, please.
Yeah. So in the meantime, you just continue. If the similar features are to be explained, you just continue. Once the Rajurkar sir come, we will just.
Okay, fine, sir. We will continue.
Yes, sir.
Many features are not
Yes, sir.
left. I mean, some features are there. We'll continue and finish it. Okay. So we'll move to the pattern. How to use this feature to create a pattern. So we have. Let's see. I have a component. I want to create a pattern of this hole on this this plate. So pattern feature is there, but it is not highlighted. Okay, so once you select the feature to be patterned, the feature is now highlighted. I want to create a rectangle pattern. So once you select the feature, it will define ask you to define the rectangle under which the pattern features will be created. Once I define, I can now define. This is the rectangle basically defined, and in that now it is asking to define the number of count. You can also change the size of the rectangle. So rectangle pattern means it will define the rectangle of default size, or whatever the size you are basically drag mouse to create it. You can define the exact value for the rectangle, and now you can define the number of instances to under that rectangle, how many instances of that hole will be created. Now the hole has been created. Now there are many options available. Now something you want to suppress it. I don't want this hole. Some of the holes I don't want. Some maybe some requirement of these holes are not required. So you can also do that. Or maybe suppose if you don't want sorry. Okay, so
Prasad sir,
yes, sir.
hi, this is going with a very nice flow, but just a request. So, can we stop for today and then we continue for tomorrow?
No problem, sir. No problem. Yes, I mean
Right. So
we
tomorrow 2 p.m. we will start, and maybe some activity we can give today so that participants can come with that activity done, and then we can continue tomorrow.
no problem, sir. No problem. Because we have
Yes.
started half an hour late. I mean, actual what we have. So otherwise, we
Right.
should.
But I think being first day, maybe people are
Yeah,
exhausted.
no problem. Yes, yes. Yeah, I
Yes.
understand.
Participant number of participants are little bit reduced there.
Yeah, no problem. I think continuing sitting and
It's going very fine, very advanced features we are getting to know from this. Yeah, it's very fine, going very fine. So, yeah.
So the attendance link is shared in the Google Meet chat, sir.
Okay.
I request participants to please respond to this attendance link, which is located in the chat box. And Santosh sir, you have shared the Google Drive. So should we share with the participants or how it is?
Sure, no problem, sir. I think
Yes.
they can download it and they can practice whatever we have discussed
Right,
today.
right. Okay, so this is the attendance and feedback link for today, sir. Just a minute, little change I would like to make. Just a minute, sir. Session. Yes. Santosh sir, you can suggest me if any changes are required. You just refresh, sir. Santosh sir, can you please refresh? Yeah, and you just suggest me the changes if any required, so that tomorrow in tomorrow's feedback form, I will incorporate all the changes.
No, nothing. I mean, basic thing is there. I mean,
Yes.
I mean, I don't think many things should be expected from the users as well. Students.
Yes.
It's okay, sir.
Yeah.
One more request, sir. Can we get the attendance list from your side? Because
Yeah, sure.
because we have already requested for AIML, so they also wanted to get to know how many people are there.